guys, we're back and we are talking this time about force and motion. So we're not talking about energy anymore. We're moving on to force and motion. They're kind of related, but I think you're going to have lots of fun in this unit. Today we're going to try to identify some familiar forces that cause objects to move. Objects don't just move on their own. They stay where they are unless something makes that happen. So we're going to look for those forces today. Remember, a force is a push or a pull. Anytime you're pushing something or pulling something, you are exerting a force. And motion is a change in the position of an object. Again, motion is a change in the position of an object. So if it was here and now it's here, something happened to make that change. You had motion, and motion requires a force. Force causes motion. Okay, so these are some of the common forces that are at work in our everyday lives. We have gravity. Gravity causes things to fall down, including your science teacher if she trips over something. It's pulling all the objects downward unless something's holding them up. If you think back to the lab we did with Ms. Kirshner, we held up the glass jar, we filled it with water, we put an index card on top, and we flipped it over. As long as we kept that index card straight and steady, when we took our hands away, the air pressure pushed up on the index card kept it there until we disturbed that air pressure and we gave it less surface. When we hit it, it all flowed down because gravity was pulling it down to the ground. So, gravity pulls objects downward unless something's holding them up. In our demonstration here, air pressure was what was holding it up. Frictional forces. Frictional forces are everywhere. Anytime you roll a ball, friction acts against it. Anytime you step down off the ground, you're pushing away and the friction's giving you that push. If you're walking in the cafeteria and someone spilled their orange juice, you might put your foot down and go to pick it up and you might not have the friction. And your foot slides and then, we fall. Because you don't have that friction. And without that frictional force, we slip. If you think about roller skating or rollerblading or skateboarding or bike riding, it's always easier on a smooth road. It's nice and easy and smooth, or maybe even writing. It's easier to write on a smooth surface than a rough surface. That's because there's less friction on a smooth road or a smooth surface than there is on a rough road. Whenever you see rough things, you're an object going across that's going to encounter a lot of friction, not just a little bit of friction. So then we're going to talk about balance forces and unbalanced forces. A balanced force, pretty self-explanatory, equal force, there's no change. We have three little kindergartners on each side. They're exactly the same height. They are exactly the same strength. And they cannot get that tug of war rope to go anywhere. Balanced forces are equal forces, and we see no change, it won't move. On the other hand, unbalanced forces, think of those same three kindergartners playing tug of war with the Hulk. The Hulk is going to win every time because those little kindergartners are a weaker force. He's pulling more, he's exerting more force. He is going to win. And those little kindergartners, they better watch out. So those are unbalanced forces, gravity, frictional forces, and balanced forces. So now we're going to get to this guy named Newton, and we're going to hear a lot about him the next few weeks. Sir Isaac Newton was born in 1642 in England. He discovered many important things about gravity and motion. If you've heard about a guy sitting under a tree and an apple falling on his head, that's Sir Isaac Newton. He talked about inertia, and this is his first law of motion. And with inertia, an object at rest stays at rest. An object in motion stays in motion at the same speed and in the same direction unless acted on by an unequal force. Now you might think, wait a minute, when I hit the ball, it doesn't go on forever. It doesn't stay at that same speed with the same motion. Eventually it falls to the ground. Well, that's because when we hit a ball, we have gravity pulling that ball back down to earth. So our force goes this way, gravity's pushing down. Once an object is moving, it doesn't need more force to keep going. It's still using that original force, and it's got that the whole time, but it's other forces working on it that slow it down or pull it down. So gravity 1 here, it pulls things down. Whenever we throw something up in the air, it kind of has this arc to it, rainbow effect, and that's because gravity slowly pulls it down. Inertia is an object's resistance to change in motion. So if we're playing pool, and I hit the pool cue, and I hit this first ball, and it hits the next one, and the next one, and finally, hopefully all of those go in the pocket. That would be a great game, you know. So I've overcome the inertia of those balls. I have forced them, I've used enough force to push them away. However, I didn't hit this ball. This 8 ball did not move anywhere. It kept its inertia. I didn't overcome that because I didn't touch it. There was no force, so it didn't move. Things only move if a force acts upon them. They only change if a force is acting upon them. And that's all we have about force and motion today. We'll see you next time.